Okay. So midterm will be this Friday. It'll be 10 questions, my usual format. I'm going to go through the slides here and just point out the things that I think are going to be important. Probably at least half of the exam is going to be programming to some extent. Um, and then I might also have some questions that will have you read code that does something and you tell me what it does. So there will be a lot of programming, as you might imagine, on a systems programming test. But the logic that I'll have you do is going to be, I guess, generally speaking, you might expect 2 or 3 questions that deal more with, um, C programming basics, because that's kind of been a new thing that we've learned as part of learning the systems programming stuff this the first 8 weeks. So there'll be a couple of questions that have you deal with, memory manipulation, string stuff. So think about some of the functions I've had you write in past programming classes where you have to reverse a string, that kind of stuff. So kind of showing me that you can do those kinds of things in C where you have to manipulate memory directly and that kind of stuff. Then there'll be, maybe a couple of questions that have you do something with forks and that kind of stuff. And I think I mentioned last time I would probably give you the little comment that says, that the process ID is returned to the parent and it's 0 if you're the child and that kind of stuff. So I want you to understand the difference between the fork stuff. So expect it to be a lot of programming, but smaller programming stuff. And then I might have a couple of questions that are, something a little bit more involved, but that I write the code and you tell me what it does. So outside of that, if we kind of just flip through these slides real quick. Did I do this last time? Flip through the slides? Okay, let me flip through the slides real quick. And I mean, obviously, it'd be fair game to say what is systems programming, but it's really a pretty broad term. So I probably wouldn't just ask it directly like that because there's 4,000 different right answers and, I guess whatever. So I probably won't ask anything about that directly. Um, kind of the concept of our operating systems, how they work together, whether we're dealing with file systems or memory. Those are kind of the 2 things that we've worked with in this um, uh, in the first 8 weeks. We've done some file I/O stuff, opening files for read write and things like that, and we've done extensive memory stuff. So certainly understand how memory works in an operating system. Understand how ALEC or malloc works. I very well might give you a question where instead of it being directly programming, I might say, assume that there's this much memory that's been allocated and you need to store this kind of stuff in it, something like that. How many total bits will you have free or something like that? So understand the concept of memory. OS history, won't be anything on there related to that. It's important from a big picture point of things, but not really part of what I'm wanting to test you on. We deal with file systems specifically. I would say maybe I would have to need it for a filler question, but maybe something with FAT32, specifically that idea of we talked about, like most of our USB sticks are formatted FAT32, where your internal hard drive on a Windows machine's NTFS, Mac it's UFS. And one of the limitations of FAT32 is that you have a limited file size. The single file can't be bigger than 4 gigabytes, 4,096 megabytes. But it's compatible for both Mac and PCs and Linux and blah, blah, blah. I would need to be looking for a filler question to ask something about FAT32, but I would say that's fair game. Process management, this is more of things that we've been talking about quite a bit. We're talking about process control blocks somewhere down here. We'll get to it in a minute. So the idea of processes, those things that the fork system call generates for us, that's going to be an important thing for us to understand. The concept of context switching, I certainly could ask you a question about it. I mean, it's something we've mentioned enough times that it shouldn't be a difficult thing anyway. But generally speaking, that's more of an operating systems concept. As from a systems programming perspective, we're reliant on the operating system to manage PCBs entering the CPU, PCBs leaving the CPU, and then that's not our problem. Other than the fact that when we write our programs, if we sit there and we create a zillion child processes, that's going to become a problem because of context switching. All right, so I would ask, if I asked a question about context switching, it would be more from the programming side of things. We're just starting to get into this idea excuse me, of inter-process communication, so I'm not going to be testing you on anything related to that. That'll definitely be heavily represented on the final. But this kind of gives us some foreshadowing into that. If you have a couple of processors and you have multiple processes running on different processors, sometimes these guys might need information from one of the other guys before they're able to run. So having communication between them gets more and more complex the more resources we're trying to share. If you have a single processor where everything is happening linearly, it's easier to schedule for that. It's easier to write maybe not easier to write system software because we're very reliant on the tools that are provided for us, right? For the most part, we've kind of hopefully gotten an appreciation when we looked at the Hello World program and assembler that even at that low-level language level, we're still using power tools. We're using those system calls from the operating system. And if we had to write that by ourselves, we would like assembly language even more than we do. So kind of the punchline there. So an appreciation for multiple processes running on multiple CPUs, but we probably don't have the context yet to ask a question about that specifically. We talked about HTTP quite a bit, so there will probably be something on there related, maybe even a couple of questions related to HTTP. I probably won't ask about handshaking specifically. It would be fair game. It should be an easy question, but that's the whole beeping stuff with your modems when they're trying to negotiate a fast speed. A fair game question related to handshaking might be, something along the lines of like, why did modems or computers need to negotiate a maximum speed that they can communicate with each other without error historically? What's the right reason for that? Why did they used to have to figure out how fast they could talk without having a mistake?
They might run at different speeds.
All right, they might run at different speeds. That's true, but we don't have handshaking today. When you get on the internet today, you just connect. It doesn't tell you what speed you're necessarily connected at. You're on a network. It might say you're on a 100 megabit or a gigabit network, but you don't necessarily know what your what bandwidth you're operating at is. But when we deal with older computers with modems and they're having to talk to each other, you hear all that beeping and stuff. They were negotiating a maximum speed that they could send information back and forth without screwing up at all. Why was it important that they didn't screw up at all back then? What were we missing? Yeah, we were missing TCP over IP. So we have transport control protocol that fixes, if a packet didn't get sent right and we need to resend it, TCP handles all that. We didn't have that back then. So we had to get it right the first time is the idea there. All right. So relatively low priority, but it's possible I might ask a question about handshaking or what the purpose of that is, and that's the whole negotiating a maximum speed that they can talk to each other without error. Again, this would be fair game, kind of how our old BBSs were set up. This is really going to be pretty related to what we're going to be starting to talk about with our multi-user dungeons when we talk about we're going to write a chat room first, but that's like first piece of that next thing. But the idea has changed with how our networked computers are set up. I mean, in a situation like this computer could have a maximum of 6 remote users because that's how many modems we had. And these 6 modems would require 6 telephone lines going into this thing. So now, if a whole bunch of people are connecting to, pick your favorite video game, the limitation is really, maybe a game lets 800 people be on the server simultaneously or something like that. And anything more than that, they think might slow down performance of the server, right? It's not that they couldn't have 5,000 people connect at the same time. Well, back then, when you have each physical connection had a piece of physical hardware associated with it, we couldn't have more than one connection coming in. So this is how it kind of used to work. Probably relatively low priority here. I would probably ask something about handshaking or TCP/IP before I asked about bulletin board systems. Sockets, there'll probably be something on there related to sockets, or at least in that world. So this is kind of our upgrade to, kind of upgrade, I guess, of connecting over a modem using handshaking. Now we have, we're reliant on a pre-existing communication network called the internet. And we're creating communication channels between 2 points on the internet. We call those guys sockets. MAC address, probably not something I'm going to ask you about. That's more of a networking concept. Same thing with DHCP, also a networking concept. Now, similarly, like network address translation, I probably won't ask you anything about that. If I asked you anything about this stuff in here, maybe the DNS stuff would be related, because that was kind of, we're talking about web type stuff, but I would really need to be hunting for a question, because, even though these are all important things that we do need to understand if we're writing network-based systems programs, it's still a networking concept as opposed to a systems programming concept. So I'm going to definitely focus more on things that fall into the category of systems programming versus the category of networking. Although you can understand there might be a little overlap there. I will probably ask something about HTTP, if nothing else, as it relates to writing your own web server or something like that. I won't ask... I certainly wouldn't ask about puts and deletes, because we didn't really discuss them. Gets and posts isn't really important to us. Again, that's more of a networking type thing. But HTTP, the idea of having a protocol, a communication, an agreed upon communication language that 2 programs use to talk to each other. That's going to be an important concept on the exam, and HTTP is the example that we've used for that. We were speaking a rough form of HTTP with our little web server we built. Yeah, so something along this line here, kind of the maybe the blueprint of a web server. That's going to be more the systems programming side of things, where we have a server here, like we wrote, that's speaking the HTTP protocol, that's doing file I/O using the file system over here. You don't have to worry so much about the MIME type stuff. That's deciding whether it needs pre-processing or something, or could it just feed HTML and JavaScript back out. But the idea of having a client make a request to the server fulfilling that request and spitting the result back to the client all over a socket. All right, that's kind of our blueprint for our web server. DDoS, again, more of a networking concept. Although systems programming is a way to perform that. So if you, depending on which side it's the networking concept if you're defending. it's a systems programming thing if you're attacking, I guess. But I likely won't ask you about that. Probably won't ask you about get versus post. Again, that's a networking thing. API stuff is going to be, I think, an important global concept. Mostly, we're going to be talking about it from our API calls of the operating system. So system calls that we've had to deal with. The file type, fopen, sockets, those types of things. Be able to read code that has that in there. I probably, if I have you do any file IO stuff, I would probably give you like the starter lines. Like you can assume that there's a variable called FP that has opened a file for read write or something like that. So I'm looking for the logic rather than, did you memorize the fopen command that you could have just copied from something, and it's not a big deal. So if I have you do something with file IO, I want you to more focus on the whole end of file stuff. Like when you reach the end of file, when do you read it in? How do you read in one character at a time? How do you read in one string at a time? Up to a buffer, that kind of stuff, as opposed to the cookie cutter. Here's the 3 lines to open up a file for reading. I'll just give you those. That's not what I want to test you on. Certainly, the concept of a REST API. I don't know what form that would take on the exam, but kind of the idea of leveraging an existing protocol like HTTP to allow us to talk to existing third-party type things. We didn't see any specific examples about it, so we might talk about it at more of a high level. So, for example, a question could be, why are modern APIs implemented in terms of REST or something like that. And the alternative to that is something called CRUD, C-R-U-D, which create, reuse, update, delete, or create, replace, update, delete. And that goes back to the HTTP protocol. That it's been around for a while, it's been time tested, it has 4 functions already associated with it, and hey, guess what? We can pretty much accomplish anything we need to do interacting with a third-party data source using those 4 functions. So that's why we use REST APIs. Again, web server stuff, probably won't ask multiprocessing stuff. Certainly fork system call, that'll be represented on there at least with one question, probably more than one question. There might be programming aspects to it. There might also be, I could ask a question, even though we didn't implement threads, I might ask about the pros and cons of processes versus threads, or, and we talked about that. Well, here, I'll just ask it out loud. So what's the difference between a process and a thread? Okay, so there's a data structure associated with that's true. Yeah, the biggest thing from our perspective, but the PCB thing is not inaccurate, because the most important thing to us from a systems programmer perspective is that full processes, which are the results of the fork system call, get their own allotment of time on the CPU, which can be a powerful thing, but also something you can abuse. Now, the cost of that, though, is they're fatter. They require more memory. They get their own PCB, and maybe the even clearer way of looking at that is they get a copy of all the code that was in the original instead of just the logic that they need to deal with. When we've had when we mess with the fork system call, it just says, I'm going to create a duplicate of this program. They're going to continue on from this line, and they have to decide who they are. Am I the original or am I the clone? And that makes that's inside of an if statement that decides what logic are they going to complete next. So there's some performance benefits from a amount of CPU time you get from a process, but there's certainly some operating system management issues. Kind of you're decentralizing your management of your processes when you have multiple processes all trying to solve the same problem, the problem within a certain application. So a program like Microsoft Word is a little bit more compartmentalized if it's spawning off multiple threads that all share the same amount of CPU time. So that if something goes wrong with one of those threads, it's Microsoft Word that crashes, as opposed to a bug in a program that's launching a whole bunch of child processes, and it gets into one of these situations where it's, is spawning off too many processors or something like that, and brings the operating system to its knees. That type of thing. So certainly understand the fork system call. Let me come back to this in a second. I want to see what else we talked about with this, if we connected it to the things on the CPU. The idea of the process control block, probably not great detail into this, but there'll be something with process control block. It's an important piece for us. We've really thought about the process ID, and that's going to become a much bigger piece for us the second 8 weeks. Because having that process ID is going to be, effectively the phone number of the other process that we need to talk to. So we start talking about inter-process communication within the same operating system. That's how we talk to the other guy, by his unique identifier. All right, so right now we don't really have a context for that. So if I talked about process control block, it would be more from the concept of the context switching side of it, and that it's the result of the fork system call, so it makes a resource intensive but potentially performance benefited type of situation. I really don't think I'm going to ask something about registers and things like that. So I probably will not ask things that deal with the compiling of code down to low-level code. It might be fair game, generally speaking. I might find a place for it on the final exam as we get into some stuff that maybe makes that make a little bit more sense. But I think we'll have enough stuff to test on that that's not a highlight. So I wouldn't worry about that stuff, this idea of the hardware registers. And I think the concept of a CPU is more important for us, since effectively that's the resource that we're sharing when we have our processes running on that. All right, so this kind of gets into that idea. Certainly the concept of blocking versus non-blocking code. That should be something that you do understand the difference between something that blocks and something that doesn't block. And how fork produces something that's non-blocking at the cost of now having this new wild animal running on the CPU, or running on the operating system. So understand this. There will definitely be a question involving, well, like I've already said, there'll be a question involving fork, but blocking versus non-blocking, I would be surprised if there's not some question that discusses that at some level. So it's that comparing, what's good about forks, what's bad about forks. Here's where we talked about the alternative, forks versus threads. I could see there being a question on forks versus threads, specifically. I don't want to go as far as to say I'd be surprised if it's not on there, but I would say there's a decent chance. The comparison between forks and threads will make it on there in one question, one way or another. I doubt, it would be fair game for me to ask what is IPC or something, but I doubt I'll include that on the exam. Almost the entire next 8 weeks is going to be dealing with inter-process communication. So that will be heavily represented on the final. This gets into more of the API type stuff. I can see asking questions about IaaS versus PaaS when we start thinking about connecting third-party APIs into our systems programming, especially when we start thinking about things are less compartmentalized on a computer. If we roll back 30 years, your average program you wrote just ran on that computer. That was it. So everything was self-contained. But now the idea, your average program today is pulling resources from different places. So there could be a question on there. I probably wouldn't ask questions comparing like Amazon Web Services versus Microsoft Azure or something like that, but there could be a question like the difference between infrastructure as a service versus platform as a service. I would have to be hunting for an extra question that doesn't take too much time because we only have 50 minutes for the exam and the programming questions are going to take a little bit longer. So I might be looking for a shorter, quick answer type question, but that would be higher priority than some of these other ones. you should know what a C compiler is, but I'm not going to ask specifically about any certain compiler. Again, you should know that a compiler converts from a high-level language to a low-level language. I doubt that would make the exam. I think I assume that you all know that by now. I could maybe ask a question about the whole thing about prototyping or header files or something like that in kind of the section where we're talking about like the fundamentals of C. Getting, that difference between a single pass and a multi-pass compiler, and why you either need to prototype functions or have a header file that you include at the top, which effectively is prototyping. That can make it onto the exam as part of that fundamentals of C thing. Again, the blocking stuff. Again, printing stuff out to the screen, fundamentals of C stuff. Be able to work with those formatted strings. I might have you do a simple little program, something along the lines of like making change or something, where you should be able to print out, how many pennies, how many quarters, and so be able to create that formatted string, the %d thing, and be able to work with strings in C. Be able to work with memory in C, certainly. You will almost definitely have to allocate some memory. Again, pointers, it's going to be on there one way or another. Similar thing with malloc. Be comfortable with the pointer syntax. This just goes into the fundamentals of C. String stuff. Here's that REST API CRUD thing. I won't ask you something specific about datagram sockets, I don't think. We may actually mess with them in our second 8 weeks. I'm not sure yet. It really depends on how the wind blows. But I would ask questions related to just sockets in general. Sockets as a tool to communicate between two programs over a network. Well, I guess technically you don't need to do it over a network, but that's what it's built for. Did I ever mention what the local version of a socket is? So we think about sockets to have two programs talking to each other, but we presume those programs are running on different computers, different places, right? So we're connecting over the internet, even though a socket will, you can loop back to and that's what we've been doing, right? Did I mention what kind of the equivalent of a socket is, but before the internet? I'd be surprised if I didn't at least mention it, but it's called a pipe. Did I mention it? Anybody? Does that ring a bell to anybody? Okay. So think of a pipe as a socket that isn't allowed to leave the machine. So we will be using pipes for one of our inter-process communication type stuff. Although it's not necessarily a convenient one, because to run a pipe, you effectively have to have like a little server set up. So that means if you want to have two processes talking to each other, one of them becomes this like, almost like the telephone operator, just listening for stuff to make requests. So it's not heavily used for what we're going to be looking at, but I would certainly ask something about sockets at the high level. This is more of a networking concept. I probably won't ask you about standardized ports or anything like that. Same thing with IP addresses, networking concept. I probably wouldn't ask anything about bitwise shifts. Technically, it would fall into the category of like a systems programming thing, but we don't have a context for like a reasonable use for it other than multiplying or dividing by 2. So I probably won't ask anything about bitwise shifts. Okay, so this is where we started talking about inter-process communication. So like I said, IPC, fair game from a conceptual perspective. But really, we're just starting to discuss this. So I would be surprised if I ask, even if IPC shows up on the exam. It's going to be super heavily involved in the the second 8 weeks. So I suppose if I just get desperate for a short question, I might ask what is IPC or something like that, just because I need a filler and the test is already too long or something. But it would have to be that. All right, again, so that's really it for the midterm. Here's a reminder for the hackathon. If you haven't already signed up, remember it's required for my classes. Otherwise, there is an alternate assignment that I will give around that time. April 14th, 8 a.m. to 8 p.m. Email Professor Josh Locklear. Let him know if you're interested in VR/AR stuff or mobile apps, so we get you onto a team that's working on that type of thing. So make sure you get signed up as soon as possible, as we're going to start beginning to put teams together. We'll have some sort of deadline that'll probably be by April 1st or something like that, because we want to get teams put together so they can start thinking about their projects ahead of time. Okay, questions about the exam? And that will be this Friday. Okay, so with that in mind, let's review what we discussed last time about our chat server, so we can start moving towards that, and then we'll start working on some of that on Wednesday. All right, so the idea is that, you know, we're going to have a server, and our chat client can exist in one of two forms. We can either rely on an existing client application, like we've been using Telnet, right? So you can rely on Telnet being your built-in tool for connecting to a remote server on a specific port, or if you wanted to, you can give yourself you can write your own chat client that maybe makes it easier for you to perform certain tasks or something like that. But we're going to focus more on the server side here for a little bit. So, you know, these chat clients, you can replace this with Telnet for now if you want. Now, out of curiosity, when might you write your own client versus just use Telnet? This is more of a broader question that has less to do with chat servers and more to do with just you know, client server type applications.
Well, what would be when you need functionality that's not offered by?
Okay, so if the existing tool doesn't give you, if you need to do something, so, you know, we look at our modern video games or something like that. Most of these games are online now, right? Well, they have all sorts of stuff that's built into them. Like, for instance, if you know, play, I don't know, Call of Duty or something like that, when you log into the server, you don't know what the URL for their server is, the domain name for the server behind the scenes. It's, you hit connect, and connect does the magic to talk to the secret server, and it's probably doing all this stuff about figuring out which server to connect to based on your character skill level, or which you know, competitions are available to you, whatever it is. But there's a tight you know, there's a tight level of communication between the server and your game client that you have installed in your Xbox, or your PlayStation, or your computer, or whatever it is. As opposed to using this generic tool that was created years and years and years ago to talk to your server, and that tool just does a bare minimum thing. It basically allows you to send text over a socket, which is fine maybe. So this kind of, you know, what we were discussing last time, we started talking about multi-user dungeons just a little bit, you know, when you could start messing around with a MUD just by telnetting into it. You know, depending on what terminal you were on, you might not get colors, you know, colored text, but it would work with just telnetting in. But once you became a pro, once you became a professional gamer for MUDs, it would no longer be acceptable to just use a telnet section, because, you know, you wanted to have a whole bunch of stuff like in macros or hotbars and stuff like that. You know, you would have a couple of clickable macros over to the side where you could say, okay, well, if I want to take a health potion, I just click on this. And what does that do? It automatically types in, you know, drink potion or something like that. So something you could have done by hand, but you want to be able to do this quickly, you know, because there's all these, I mean, otherwise every time you play, it's like writing a paper. You might also have some shortcuts to places, like you want to get to. Let's say there's a certain dungeon you go to often. You might have that shortcutted in there where you just click on something, or you do a macro like /F1, and it just takes you through the whole path to get there. All the different turns and things like you would do for that. So these are kind of like IDEs for programming, right? Nothing says we can't program with Notepad, okay? But we prefer using IDEs in many cases because they make the life of a programmer easier in many cases by doing some of the stuff for us. So with that in mind, you had this creation of kind of generic clients. So it wasn't really relying on Telnet, and it wasn't really creating a client specifically for a certain MUD. Instead, you had these MUD clients that were effectively Telnet on steroids, and they would work with pretty much any MUD, but had some stuff built into them that would make your life easier. And we see similar things to that today. If you're in gaming and stuff today, and you use Discord or TeamSpeak or something like that, there are various clients that are compatible with Discord or compatible with TeamSpeak that might allow you to manage your various servers more easily, or different things like that. So that becomes more of that generic middleware type thing for a client versus a very proprietary type client. So when you play Call of Duty, the client program for that is a significantly different program. It might do many similar things, but it's a significantly different program than the client for World of Warcraft or something like that, because those clients are built to tightly integrate with the server. Okay, so initially we won't have anything special about our client. We might end up writing something more specialized as a client, but we're going to be looking at it from a server perspective initially. So if we have two people living in different parts of the world, or living down the street, or sitting across the lab from each other, or I guess in our case, even sitting on the same computer at the same time and fighting for the keyboard, we'll telnet to a server. The server will spawn off a child, just like we did for HTTP, just like for our web server. Similarly, this guy will connect to the servers. The server will spawn off a child. So now you have this child process, a full PCB, that is handling the communication with this connected socket. All right, but now the nature of the problem we're solving is different when we're dealing with a chat server than it is when we're dealing with a web server. So when we built a web server, the nature of the communication between the child and the server was just, give me a web page, server spit out the page. Done. It's a one and done situation, disconnected afterwards, and that was it. Well, with a chat server, we expect there to be more going on than that. So at the very least, the connected client is going to be able to send as much stuff as they want to the child server, okay, to their server that's connected to them. So they could say, hey, how are you, blah, 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 whatever they want to say. Now, similarly, this client's going to be able to send as much stuff as they want to this child. Now, in the ideal world, this client will see the stuff that this client is typing, and this client will see the stuff that this client is typing. Okay? So we want this scenario where this client is sending information directly to this client. But in a client-server model, when we're writing programs that are client-server based, we don't have this direct connection like this. This is usually called a peer model, or a peer-to-peer model. All right, so these two chat clients would be peers. They talk directly to each other. This is kind of how the BitTorrent network works. All right, so the BitTorrent network effectively gives you a collection of nodes that are on the network, collection of peers, and those peers are either seeding files or downloading files. Usually they're doing both, with the hope that once the file is done downloading, the network kind of relies on people to continue to let their torrent upload. But what do most of us do? As soon as it's done, you disconnect it, delete it, so you might get caught, right? Less time you're online, the better. You're doing only legal stuff, obviously. All right, so since this isn't part of our world here, we need to have a way for our clients to talk to our other clients through the server. Now, from our picture here, we really have 3 servers, right? This guy here in the middle is the guy who's just listening for new incoming connections and then spawning off a child. But he's still running. He's still kicking. And what's important to note here is that this server right here is the only guy that knows about the process IDs of all the children he's spawned. And that might be handy. A little bit ago, I mentioned that the process ID of a PCB, of a process, PCB is not accurate, but, well, actually, I guess it is accurate. It's the data structure that has the process ID. So the process ID of a process is like its unique phone number on the system. So that's our way of kind of calling out to that guy and talking to him directly through one of our inter-process communication mechanisms that exists on in that operating system. All right, so our operating systems are providing us with a list of tools that allow for processes to talk to each other in different ways. Okay, now one of the ways I mentioned last time was this idea of shared memory. All right, so you can think of shared memory as kind of being like a shared variable. And it was the easiest one to kind of introduce conceptually initially, because when you have a server and the server forks a child process, what you do is you get copies of all the variables. But now they are independent copies. If you change something over here, even if it was based on memory, it doesn't change here. You're getting a whole new memory footprint for these two, well, for the original server and now the child. With shared memory, what you can do is you can create a variable that's based on shared memory, that when that split occurs, it's still the same variable. Okay, it's not a copy. It's like a shared repository. Okay, so with that in mind, it's, you can then use that tool where maybe this guy writes something to that shared memory, and this other guy then on some sort of cadence checks what's in the shared memory. Or maybe what happens here is the chat server, when he first launches, he spawns off a broadcast server, something like that. So what happens is right off the bat, the chat server spawns off a child. Now the point of this child is to constantly check that shared memory. And if there's anything in there, he's going to broadcast it to all the connected sockets. All right, so he kind of has a copy of all the sockets that ever get connected. That way he can broadcast to everybody. So he's always just checking to see if there's messages available, and he runs through the pipe. Another possibility is when a child connects here, he might have a list. Maybe it's an array. So maybe we have a shared memory of the array of all the sockets. And then each child can broadcast to everybody but themselves. All right, so in our model here, it might be helpful for us to have kind of I mentioned last time, this is almost like a singleton. It might be helpful for us to have a global array filled with all of our sockets. Because at the end of the day, we don't necessarily care about the processes. We just need to be able to send information to the end client. The fact that there are multiple processes in the machine is insignificant to us. So we might want to have a chunk of shared memory that holds a list of all of our sockets that have been connected, so we can send stuff to them. Make sense? All right, so we'll come back next time. We'll talk about shared memory. And if you have any questions that you want me to review before the test on Friday, I can address those on Wednesday as well. Don't forget to sign up for the hackathon. And also, remember, the CS get-together is this Thursday, 11:30 to 1, right down the hall. Show up early, do that little get-together thing, because that's where the good prizes are, all that stuff. Definitely show up.